So today we're going to study graph traversal BFS, breadth first search. Before moving to the algorithm, I request you to get through the concept of graphs and how to represent graphs. So we will apply breadth first search to an undirected and weightless graph. So here you can see it has around 6 nodes. So we'll perform a BFS traversal on this graph. Okay, what is BFS? Breadth first search, as the name suggests, will explore the neighbors first, all the neighbors. Then we'll go to the deeper level to their adjacent neighbors. Okay, so I can represent it as, suppose we are at 0. Okay, we'll go explore 2, we'll go explore 1. Okay, now after that, uh, we'll go explore 4, then we'll go explore 5. Okay, then we come back to 2. Okay, for 1 we will explore 3. So the traversal will be like this. Traversal will be 0, 1, then 2, then 0, 1, 2, yeah, then 3. We'll first explore 1's neighbor, 3. Then we can explore 2's neighbor. Who are 2's neighbor? 4 and 5. Go 5, we can go 4, we can go then 5. Okay, this is one traversal. We can also move like this. Suppose from 0 we can go to 2, then we will go to 1. So we'll explore 2's neighbors first. So we'll explore 4, then we'll explore 5. Then after all the neighbors visited, we'll explore 1's neighbor. Okay, 1's neighbor. Who are 1's neighbor? Only 3. So we'll explore 3. So there are many paths. Okay, so many paths are possible for this BFS algorithm. So now let's do write the algorithm for the graph. So we'll first make a adjacent list of this graph. So you know how to make adjacent list. We'll make, okay, so first for 0 we'll make, who are the neighbors of 0? 0 and 1. Sorry, who are the neighbors of 0, 1 and 2? Write 1, write 2 here. Okay, then we'll explore 1. Who are the neighbors of 1? 0 and 3. Correct. Okay, neighbors of 2, 4 and 5. 4, 5 and 0. Okay, 0, 4, 5. For 3 only 1. For 4 only 2. Okay, for 5 only 2. Okay, only 2. Right. So now in the algorithm, what we do is we keep 2 data structures. One is a queue and one is a array that will mark the elements visited. Okay, so we'll maintain 2 data structure. First we'll maintain a array that is of length of the total nodes of the graph. Okay, so 0, 1. Okay, so here 0, 1, 2, sorry, 0, 1, 2, 3, 4, 5, 6 nodes. All right, and we'll maintain a queue. Okay, we'll maintain a queue. This is the front part, this is the rear part. Okay, now we'll write the algorithm. So the algorithm is push. Okay, so algorithm is correct. Okay, let's perform this on this array, on this graph. Okay, so first we are at if I to erase it, we'll start from scratch. Okay, we start with 0. Okay, we start with 0. So first we'll do is, first we push this source node into queue. Okay, so Here we push 0. Now Q is not empty, so we'll pop it. We pop the element for each neighbor of current. Who are the neighbors of current? 1. Okay, so we got 1. We'll push the neighbor into Q. We pushed it and we mark it visited. Okay, so yeah, initially when you push something, you mark it visited. So you can say mark visited. So 0 is visited. Okay, now we were at 1, so now we'll mark 1 as visited. Correct. Okay, visited. Then the second neighbor. Who are the second neighbor? 2. Correct. So we'll push 2 into the queue. We'll mark 2 as visited, right? So we went like 0, then 1, then 2. Okay, now all the neighbors are visited. Okay, so from this loop we exited. Again, while queue is not empty, we'll pop an element. Which element to pop? From the first front, we'll pop 1. Okay, so we'll pop 1. Now we pop 1. Who are the neighbors of 1? 0 and 3. But 0 is already visited. Okay, 0 is already visited. So we'll move to the next neighbor. Move to 3. 3 is visited. 3 is not visited. What we'll do? Push it into queue. What we'll do? Push mark it visited. Okay, we marked it visited. Correct. Now we went like we went to 3. Okay, now all neighbors of 1 are visited. So we'll check while Q is not empty. Q has 2 elements, and who is at the front? 2. So we'll pop the 2. Who are the neighbors of 2? 0. Right? 0, 4, 5. But 0 is visited. So we'll go to 4. Right? So we'll push 4 into the queue and we'll mark 4 as true. Visited also. So also 5 is also the neighbor. We'll push it into the queue. We'll mark 5 visited as true. Correct. And are there any more neighbors? No, there are no more neighbors. Okay. Now what we'll do, all the neighbors are checked. Okay. Is the queue still empty? No, the queue is not still empty. What we'll do, we'll pop the neighbor. Correct. We'll pop the neighbor 3. Is there any neighbor of current? The 3? Yeah. The neighbor is 1, which is already visited. So we'll move to another element. We'll pop one more element. Who is it? 4. So we'll pop 4. Now 4 is visited. 4 is already visited. Any neighbors of 4? 2. So 2 is already visited. Right. 2 is already visited. We move to 4. No neighbors. Okay, we come back. We then pop the next element while the empty queue is not empty. Who is that? 5. We'll pop 5. Are there any neighbors of 5? Yes, 2. 2 is already visited. Okay, 2 is already visited. So visited 5. Okay, now we visited all the nodes. Correct. So I think this is this 0, 1, 3. This one we did. This traversal we did, and the now lastly now the queue is empty. So this loop stops. Okay, so this was the breadth first search algorithm. You can write it in any language. So okay, so this was the graph traversal for BFS, breadth first search. Hope you like it. If yes, please hit like and comment. Okay, for now, please, if you like it, put a like and please comment. For now, Thanks.